si Nicole Nobong, a grade 12 student of Immaculata High School, and this video will be all about ideal gas. An ideal gas is a theoretical gas composed of set of randomly moving point particles that interact only through elastic collisions. In ideal gas, the gas molecules move freely in all directions, and collisions between them is considered to be perfectly elastic, which implies no loss in the kinetic energy due to their collision. To study the property of gases, we need to have a standard gas to study. And there are thousands of gas we could study, but the researchers have found that no matter what gas you study, if you take a 1 mole sample of that gas and put it in the same container and maintain at a constant temperature, the pressure is almost the same. And at the lower densities, even those tiny differences in the measurements also disappear. Thus, at really low densities, all the real gases tend to obey one universal law called ideal gas law. This law is described by an equation known as the ideal gas equation. PV equals nRT, where P is the pressure of the ideal gas, V is the volume of the ideal gas, N is the amount of ideal gas measured in terms of moles, R is the gas constant, and T is the temperature. Although the ideal gas equation has many limitations, this equation holds well along as the density is kept low. This equation is applicable for single gas or even a mixture of multiple gases, where N will stand for the total moles of gas particles in the given mixtures. The equation states of an ideal gas explains the simple relation between the parameters or properties that are very generic and accurate. In general, an equation relating the relation between P, V, and T of an ideal gas is called equation of states. The ideal gas equation can be written in multiple ways depending upon its disciplines. In common form, the most frequently used form of the ideal gas equation is PV equals nRT equals N K sub B T, where P is the pressure of the ideal gas, V is the volume of the ideal gas, N is the amount of ideal gas measured in terms of moles, R is the gas constant, T is the temperature, N is the number of gas molecules, K sub B is the Boltzmann constant, and N sub Ka is the Avogadro's constant. In molar form, this alternate form of the ideal gas equation is useful because it specifies the amount of gas accurately. The molar form is given as PV equals R specific T, where P is the pressure of the ideal gas, V is the specific volume, R specific is the specific gas constant, and T is the temperature. And lastly, in statistical mechanics, the equation is given by this, where P is the pressure of the ideal gas, T is the temperature, and this is the average particle mass, Mu is the atomic mass constant, P is the density, and K sub B is the Boltzmann constant.